Question 1. The step graph shows the cost of telephone calls to China. Bella made a telephone call at 9:50 p.m. to a friend in China and spoke to him until 10:07 p.m. How much did this telephone call cost? Now the x-axis of the step graph represents the length of time that the phone call took. So in this case, from 9:50 p.m. to 10:07 p.m, that's 17 minutes. And one easy way to work that out is 9:50 p.m. to 10 p.m. is 10 minutes. And from 10 p.m. to 10:07 p.m. is another 7 minutes. So again, that makes it 17 minutes. Let's locate 17 minutes on the x-axis. So somewhere midway or between 15 and 20. So maybe approximately there. And if we take a ruler and project upwards, we can see clearly which step the vertical line is going to strike. So it strikes the top step, and that top step is the $16 step. So that's the step from 15 minutes onwards. So the answer is D. Question 2. A measurement of 72 centimeters is increased by 20% and then the result is decreased by 20%. What is the new measurement correct to the nearest centimeter? So starting off with 72 centimeters, increasing that by 20%, we multiply by 120%, and then decreasing that by 20%, we multiply it by 80%. So 100 minus 20%, which is 80%. To give us a total of 69.12 centimeters, and correct to the nearest centimeter, that'll be option B. Question 3. The diagram shows the graph of an equation. Which of the following equations does the graph best represent? Now this U-shape curve is called a parabola, and that corresponds to an equation where the power of x, or the highest power of x, is a 2. And option C is the only equation where the power of x is 2 and it is also the highest power of x. So it's option C. Question 4. Young's formula below is used to calculate the required dosages of medicine for children aged 1 to 12 years. How much of the medicine should be given to an 18-month-old child in a 24-hour period if each adult dosage is 45 milliliters? The medicine is to be taken every 6 hours by both adults and children. Now the first step is to convert the child's age into years. So 18 months is equal to 1.5 years. We can substitute that into the formula directly. So the dosage is equal to the age of the child in years, so that's going to be 1.5, multiplied by the adult dosage, so that's multiplied by 45, over age of the child in years again, so that's going to be 1.5 plus 12. And calculating that, we have 1.5 multiplied by 45 over 1.5 plus 12, and we have 5 milliliters. However, that's to be taken every 6 hours for 24 hours, so that'll be 4 dosages, so we need to multiply that by 4. So the total is equal to 5 multiplied by 4, and it'll be 20 milliliters. So answer is B. Question 6. A cafe menu has 3 entrees, 5 main courses and 2 desserts. Ariana is choosing a 3-course meal consisting of an entree, a main course and a dessert. How many different 3-course meals can Ariana choose? I'm going to use a tree diagram to answer this question, and I've drawn part of the tree diagram already. So starting off with the entrees, we have a choice of 3, so call them entree 1, entree 2, entree 3. Now for each of the entrees, there are 5 main courses that Ariana can choose from. So 1, 2, 3, 4, 5. And likewise for E2 and also for E3. So we have a choice of 3 there. For each of the entrees, there's a choice of 5 main courses. And for each of the main courses, there are 2 desserts. And so on. So it's important to see the pattern here. So for every entree, there are 5 main courses, and for every main course, there are 2 desserts. So 3 times 5 times 2 equals 30, and the answer is 30 different meals that Ariana can choose. Question 7. Which of the following is the graph of y equals 2x minus 2? This is in the form y equals mx plus c. So the m represents the gradient, so the gradient's 2. So from left to right, the line is rising, and the negative 2 indicates the y-intercept. So let's consider the y-intercept first, because that's kind of the easiest thing to look at. That's a y-intercept of 2, so it can't be b. That's a y-intercept of negative 1, so it can't be c. So we have an option of A or D. Now with A, the gradient from left to right is negative, and for D, the gradient from left to right is positive. The gradient's positive 2, so the answer must be D. Question 8. A group of 150 people was surveyed and the results recorded. A person is selected at random from the surveyed group. What is the probability that the person selected is a male who does not own a mobile? So this is a two-way table. The first thing to note is the number of people surveyed, so that's 150. So the probability will be out of 150, but we may have to simplify the fraction perhaps, we don't know. Now let's select the correct cell. So we need this row, so male and does not own a mobile. So we need this column, and we then select the number 28. Let's put that in the fraction there. So it's 28 out of 150. And is there a 28 out of 150 there? Yes, there is. It's unsimplified, but that is the correct answer. Question 9. A car is bought for $19,990. It'll depreciate at 18% per annum. Using the declining balance method, what would be the salvage value of the car after 3 years to the nearest dollar? So we use the declining balance formula, which is value is equal to the initial value, which is $19,990, multiplied by 1 minus 18%, which is the depreciation rate per annum, to the power of 3, because it's over 3 years. So this is what you'd enter into your calculator, press equals, and it's $11,022 correct to the nearest dollar. So it's option C. Question 10. The top of the Sydney Harbour Bridge is measured to be 138.4 metres above sea level. What is the percentage error in this measurement? Now there's three things we need to consider. The first is the precision or the accuracy of the measurement. So we can see here that it's measured accurate to 1 decimal place or 0.1 metres. The next thing we need to work out is the absolute error, and that is half times the precision, or half times 0.1 metres, which is 0.05 metres. And finally, the percentage error is worked out by taking the absolute error, dividing it by the measurement itself, which is 138.4 metres, multiplying it by 100, and the result is 0.036%. So answer is A. Question 11. Simplify 6w to the power of 4 multiplied by 1/3 w squared. Now one helpful strategy would be to write the expression in expanded form. So putting the multiplication sign between the 6 and the w to the power of 4 and between the 1/3 and the w squared. So this expression can be written as 6 multiplied by w to the power of 4 multiplied by 1/3 multiplied by w squared. Now because all these terms are being multiplied together, that can happen in any order. So let's multiply the numbers first. So 6 multiplied by 1/3 is equal to 2. And w to the power of 4 multiplied by w squared is w to the power of 6, based on one of the index laws, where we add the indices together when you're multiplying two terms with the same base. So the answer is 2w to the power of 6, and that will be option A. Question 12. A path 1.5 metres wide surrounds a circular lawn of radius 3 metres. What is the approximate area of the path? Now this can be found by finding the area of the outer circle and subtract from that the area of the inner circle. So it's the area of a composite shape. Now the radius of the outer circle is 3 metres plus the width of the path, so that gives us a radius of 4.5 metres. And of course the radius of the inner circle is 3 metres. So area of the outer circle minus the area of the inner circle, and that's it there on a calculator, Press equals and you'll get 35.3429, and that rounds to 35.3, option C. Question 13. Jane sells jewellery. Her commission is based on a sliding scale of 6% on the first $2,000 of her sales, 3.5% on the next $1,000 and 2% thereafter. What is Jane's commission when her total sales are $5,670? So what I've done is to use a number line to break up this amount of $5,670 into the three tiers. So the first $2,000 attracts 6% commission. The next $1,000 attracts 3.5% commission, and the balance is found by subtracting 3,000 from 5,670. So this 3,000 is obviously 2,000 plus 1,000, and that gives us a balance of $2,670, and that attracts a commission of 2%. So her total commission is 6% of $2,000 plus 3.5% of $1,000 plus 2% of $2,670 to give us a grand total of $208.40. So it's option B. Question 14. 20 Year 12 students were surveyed. These students were asked how many hours of sport they play per week to the nearest hour. The results are shown in the frequency table. What is the mean number of hours of sport played by the students per week? Now, because we're dealing with class data, we need to find the midpoint of each of the classes first. So the midpoint of 0 and 2 is 1, the midpoint of 3 and 5 is 4, 6 and 8 is 7, and 9 and 11 is 10. Next, we can use the stat mode on the calculator to determine the mean. So mode and stat, so let's press that, and one var, so only dealing with one variable statistics. Notice that we don't have a frequency column, so we'll bring that up by pressing Shift, Setup, scroll down, and then number 4, stat, and frequency on. Now we can enter in the data from the table. So I'm going to enter in these midpoints first. So 1, 4, 7, and 10. Next, I'll enter in the frequency of each of these classes. So 5, 10, 3, and 2. Then press AC, Shift 1, and then number 4, var, and then option number 2 for the mean, and we get 4.3. So that's option B. Question 16. In Mattsville, there are on average 8 rainy days in October. Which expression could be used to find a value for the probability that it will rain on 2 consecutive days in October in Mattsville? Now, this is an example of independent events. So on any particular day, if it rains, it does not affect or change the chance of rain on the subsequent day. So I've modeled this situation using a tree diagram. So let's say it rains on a particular day. The chance of rain is 8 over 31, since there are 31 days in October. The chance of rain on the next day is still 8 over 31. And to find the probability of rain on these 2 consecutive days, you multiply the probabilities. So it's 8 over 31 multiplied by 8 over 31. So it'll be option D. Question 17. A child who weighs 14 kilograms needs to be given 15 milligrams of paracetamol for every 2 kilograms of body weight. Every 10 milliliters of a particular medicine contains 120 milligrams of paracetamol. What is the correct dosage of this medicine for the child? So now the first thing probably to note is the mass of the child is 14 kilograms. We know that we need 15 milligrams for every 2 kilograms of body weight. So 2 goes into 14 7 times. So the amount of paracetamol is going to be equal to 14 divided by 2. So that's the number of lots of 2 kilograms in 14. Multiply that by 15 milligrams. Okay, and we get, so 14 divided by 2 multiplied by 15, we get 105 milligrams of paracetamol. Now, we know that the rate of, or the rate of weight of paracetamol to the actual volume of the medicine is 120 milligrams to 10 mils. Okay, or we can say for every 10 milliliters, there's 120 milligrams of paracetamol. So why don't we do it in that direction then? So we know that 10 milliliters of the medicine contains 120 milligrams of paracetamol. Now, we can use the unitary method again to solve this, and we've used the unitary method in many other questions in the past. So once again, unitary method saves the day. So let's work out how many milliliters per 1 milligram of paracetamol. Okay, so 10 divided by 120 milligrams, so that gives us the milliliters per milligram. Multiply that by 105 milligrams, of course. Working that out quickly, we get 10 divided by 120 multiplied by 105, and we get 8.75 milliliters. So answer, option B. Question 18. The average New South Wales annual water consumption from the residential sector is equal to 90,340 litres per person per year. The Building Sustainability Index, BASICS, uses this as the benchmark to set a target for reducing water consumption by up to 40%. A new building, planned to house 50 people, has been designed to meet a 25% reduction on this water consumption benchmark. How much water per year to the nearest kilolitre is this building designed to save when fully occupied? Now, I think the first thing we need to work out is how much water 50 people are going to use in the year. So I'm just going to write down 90,340, and that's the consumption of water per person. So we need to multiply that by 50 because there's going to be 50 people in this building. Now, this 40% here is of little relevance in this question. So we just need to be mindful that not all the data given in the question is needed. What we do need though is this 25%. So this building is designed to save 25% on this target. So we're going to multiply that by 25%. Okay. And let's see what we get there. Okay, so 90,340 multiplied by 50 multiplied by 25. And we get 1129250. Now that's in litres, we need to convert that into kilolitres. So we divide that by 1,000 and we get 1129.25. And that's kilolitres. Okay, and the closest answer to that is option A. Question 19. Jazz has 2 bags of apples. Bag A contains 4 red apples and 3 green apples. Bag B contains 3 red apples and 1 green apple. Jazz chooses an apple from one of the bags. Which tree diagram could be used to determine the probability that Jazz chooses a red apple? Now this is a multi-stage event, so it consists of 2 stages. Stage 1 is to choose a bag, bag A or bag B, and there's a 50-50 chance of one or the other being chosen. So if you look at option C and D, the first stage does not refer to the bag or what bag to choose. So option C is out and option D is automatically out. That leaves us options A and B to choose from. So we have a 50-50 chance of choosing bag A or bag B for the first stage. Now the second stage is to choose the colour of apple. Let's go back to the question. Bag A contains 4 red apples and 3 green apples, so that means there's 7 apples in total. And the probability of choosing a red apple from bag A is 4 out of 7. And if you notice with option A, so let's say Jazz chooses bag A, there's a 4 in 7 chance that a red apple would be chosen. If you look at option B, just for comparison, bag A, 7 out of 11, well, that doesn't make any sense because there's only 7 apples. So option B doesn't make any sense, and that leaves us with option A. Question 20. In a household of 4, each member uses an average of 13 minutes of hot water per day. The household uses a 9 kilowatt hot water unit. Electricity is charged at 11.97 cents per kilowatt hour when the hot water unit is being used. What is the electricity cost for the hot water used by this household in 1 week? Now, the first thing we need to work out is the number of minutes a day this hot water unit is being used. So 4 people multiplied by 13 minutes per person gives us 52 minutes per day. Now, the next thing we need to work out is the number of minutes per week. So 52 minutes per day, multiply that by 7 days in a week, we get 364 minutes in a week. The next thing we need to work out is the number of hours per week that translates to. So when we're working at electricity cost, the time must be in hours. So we take 364, we divide it by 60, and we get 6 1/15 of an hour per week. The next thing we need to work out is the energy consumed. That's in kilowatt hours. So we take the number of hours used, multiply that by the power rating of the unit itself. So 6 1/15 multiplied by 9 or 9 kilowatts is equal to 54.6 kilowatt hours. The final thing we need to work out is the cost. So we take the energy used, so 54.6 kilowatt hours, multiplied by the cost of electricity in dollars per kilowatt hour. Notice that in the question, it's given in cents. So we need to convert that into dollars first. So that's 0.1197. Multiplying all that together, we get $6.54. So it's option B. Question 21. A table of future value interest factors is shown. A certain annuity involves making equal contributions of $25,000 into an account every 6 months for 2 years at an interest rate of 4% per annum. Based on the information provided, what is the future value of this annuity? The first thing we need to work out is how many periods this equates to. So this annuity goes for 2 years, but the contributions are made every 6 months. So there are 4 lots of 6 months in 2 years. So we need to select this row, the final row. And the interest rate is 4% per annum. So that's per 12 months. But the annuity is compounded every 6 months. So we need to divide this interest rate by 2. So we need this column here, which means this is the interest factor that we need to multiply the contribution by. So the value of the annuity, we take the contribution, multiply it by the interest factor, so 4.1216, 4.1216, and we get $103,040. Option C. Question 22. Heather's car uses fuel at the rate of 6.6 litres per 100 kilometres for long distance driving and 8.9 litres per 100 kilometres for short distance driving. She used the car to make a journey of 560 kilometres, which included 65 kilometres of short distance driving. Approximately how much fuel did Heather's car use on the journey? So the first thing we're going to do is we're going to split up the 560 kilometres into short distance driving and long distance driving. So I'll just say short distance is 65 kilometres. The long distance component is 560 minus 65, which is 495 kilometres. Okay, now to calculate the fuel consumption for both of these components. So the short distance fuel okay. Now, we're going to use the unitary method. So for short distance driving, it's 8.9 litres per 100 kilometres. So we're going to work out the fuel consumption per kilometre. So we're going to take 8.9 litres, we're going to divide it by 100, then we're going to multiply it by the actual kilometres travelled, which is 65 kilometres. And that's equal to 8.9. We're going to divide that by 100, and we're going to multiply that by 65, and we get 5.785 litres. Okay. Now, for long distance fuel consumption, Okay, and long distance fuel consumption's less per 100 kilometers, so it's 6.6 divided by 100. So again, using the unitary method, multiplied by the long distance kilometers, which is 495. Okay, so 6.6 divided by 100, multiply that by 495, and we get 32.67 litres. Now, if we add both of those numbers together, so 5.785 plus 32.67, we get, well, 38.455. So the closest answer will be B. That's correct to the nearest litre. Question 23. The following information is given about the locations of three towns, X, Y, and Z. X is due east of Z. X is on a bearing of 145 degrees from Y, and Y is on a bearing of 060 degrees from Z. Which diagram best represents this information? Now, the first point, X is due east of Z, implies that X is situated to the right-hand side of Z. So it's either options A or C, since X is on the right-hand side of Z. Now, the third point, Y is on a bearing of 060 degrees from Z, is satisfied in both these options. Now, the second point, X is on a bearing of 145 degrees from Y, is the one that is going to require a little bit more time. Now, to help with the explanation, what I've done is I've redrawn the triangle here. It's not the scale, of course. And X is due east of Z. And Y is on a bearing of 060 degrees from Z. So I've filled in another angle here. So this is 30 degrees because it's complementary to 60 degrees. Of course, since X is due east of Z, so this is the east-west axis, and there's 90 degrees between north and east. Now, we know that X is on a bearing of 145 degrees from Y. So what I've done is I've drawn another north-south axis, so from Y, but just sort of upwards in a northerly direction. And these two north-south axes are obviously parallel with each other. So that's 145 degrees. Now, since these two sets of axes are parallel, we can use parallel line geometry. So if that's 60 degrees here, this angle here, so NYZ, is co-interior, which means that these two angles must add up to 180 degrees. So that's 120 degrees there. And angles at a point add up to 360 degrees. So 360 minus 120 minus 145, actually I might just write that here. So 360 minus 120 degrees minus 145 degrees will give us 95 degrees. And so the correct answer is option C. Question 24. The weights of 10,000 newborn babies in New South Wales are normally distributed. These weights have a mean of 3.1 kilograms and a standard deviation of 0.35 kilograms. How many of these newborn babies have a weight between 2.75 kilograms and 4.15 kilograms? Now, the first thing to note is that the weights are normally distributed, which means I'm going to use Z-scores to find the percentage under the normal distribution that corresponds to these two weights. So let's find the Z-score for 2.75 kilograms. So I'll call that Z1 is equal to 2.75 minus the mean, 3.1, divided by the standard deviation, 0.35, and that gives us -1. And likewise, the Z-score for 4.15 kilograms is calculated in a similar way. So I'll call it Z2, is equal to 4.15 minus 3.1 divided by 0.35, and we get a Z-score of 3. So if we visualize that on the normal distribution, okay, so there's a Z-score of -1, Z-score of +3, and the percentage under the normal distribution between these two Z-scores can be worked out this way. Between -1 and 0, we know there's 34%. And between 0 and 3, the way I work that out is, I know that 99.7% of the data lies between -3 and +3. You can get that from the reference sheet. Dividing that by 2, because we're only interested in 1/2 of the normal distribution, and that gives us 49.85% in this region. So the number of babies is equal to 10,000, so that was the number of babies surveyed in terms of their weights, multiplied by the sum of these two percentages, so 34% plus 49.85%, I'll just put that in brackets. Multiplying that together, we get 8,385 babies that lie between the two weights specified, and that's option D. Question 25. A grain silo is made up of a cylinder with a hemisphere, half a sphere on top. The outside of the silo is to be painted. What is the area to be painted? Now the first thing to note is the diameter of the silo is 48 meters and the height of the cylindrical part of the silo is 30 meters. So the first thing we'll work out is the radius, and the radius is half the diameter, so the radius R is 24 meters. The next thing we'll work out is the surface area of the silo wall, so just the curved surface of the cylinder, and that's 2 pi times R times H, for the height of the cylinder, and that gives us 4,523.89 square meters. The next thing we'll work out is the surface area of the hemisphere, and we'll do that by working out the surface area of a sphere and then dividing it by 2. So the surface area of a sphere is 4 pi r squared, but we'll divide that by 2 to get the half sphere, or the surface area of the half sphere. And that's 3,619.11. Now the total surface area is 4,523.89 plus 3,619.11, and that gives us 8,143 square meters, and that's option A. Question 26a. Expand 4x outside of 7x to the power of 4 minus x squared in brackets. We need to apply the distributive law here. The term on the outside multiplies each of the terms on the inside separately. So this will be our first line of working out. So 4x multiplied by 7x to the power of 4 minus, so it comes from this minus here, 4x multiplied by x squared. Our next step is to simplify this expression. So 4x multiplied by 7x to the power of 4, you multiply the numbers separately and multiply the pronumerals separately. So 4 times 7 will be 28. X multiplied by x to the power of 4 is x to the power of 5. So the power of this x here is a 1. Likewise with 4x multiplied by x squared, 4 times 1, there's an invisible 1 here, 4 times 1 is 4, and x times x squared is x cubed. And we end up with our solution. Question 26b. Calculate the value of h correct to 2 decimal places. Now we're dealing with a right angle triangle, which means either Pythagoras theorem or right angle trigonometry will need to be applied. Now Pythagoras theorem is applied when we have two known sides, and in this case we've only got one known side and the other side's unknown, and we have no idea what's going on with the third side, which leaves us right angle trigonometry. So we have a known angle, we have a known side, we'll need to find the unknown side. The next thing is whether we use sine, cos or tan, and that depends on where the sides are relative to the 28-degree angle. Now the 5 is opposite the 28 degrees and h is the hypotenuse. So from SOHCAHTOA, SOH, we need to apply the sine ratio. So sine of 28 degrees is equal to 5 over h. So that'll be the first equation I would write. The next thing is I would need to solve for h. Now notice that h is in the denominator, not in the numerator. The next thing is to multiply both sides by h, or I could move the h over and multiply the sine 28 degrees by h, and that equals 5. Now to make h the subject of the formula, we would need to divide both sides by sine 28 degrees. So h equals 5 divided by sine 28 degrees. And evaluating that, we get 10.65. Question 26c. Solve the equation 5x plus 1 all over 3 minus 4 equals 5 minus 7x. There's two ways we can start this. You can notice that we have a -4 on its own, and we also have a 5 on its own, and we can move that -4 over by adding 4 to both sides. The other way we can do this is to multiply each of these terms by 3, which eliminates this denominator of 3 in the first term. So I'm going to do just that. I'm going to multiply each of these terms by 3 to eliminate this denominator first. So we end up with 5x plus 1, since 5x plus 1 over 3 multiplied by 3 will cancel that denominator. Now 4 times 3 is 12, so minus 12. 5 times 3 is 15, and 7 times 3 is 21x. So we have 5x plus 1 minus 12 equals 15 minus 21x. The next thing to note is on the left-hand side we have a plus 1 minus 12, so that can be simplified. So we have 5x minus 11 equals 15 minus 21x. The next thing we need to do is to move the pronumerals to one side and the numbers or the constants over to the other side. So I'm going to move the pronumerals or the terms involving the pronumeral to the left and the constants or just the numbers on their own to the right. So minus 21x or negative 21x, when that's moved over from the right hand side to the left hand side, becomes positive 21x. And negative 11, when that moves to the other side, so from the left to the right hand side, the negative 11 changes and becomes positive 11. It's the same as adding 11 to both sides. Negative 11 plus 11 eliminates the negative 11, but then you need to add 11 to the other side to compensate for that. Now it's just a simple case of combining the like terms. So 5x plus 21x, you get 26x equals 15 plus 11, which equals 26. And of course, dividing both sides by 26, x equals 26 divided by 26. We have, therefore, x equals 1 as the solution to this equation. Now, don't forget, if you've got some time, and try to factor in some time into this, don't forget to verify your solution. If you substitute x equals 1 into the left-hand side and then into the right-hand side, you should find that the left-hand side or the value on the left-hand side should equal the value on the right-hand side. Question 26D. Solve these simultaneous equations to find the values of x and y. We have y equals 2x plus 1 and x minus 2y minus 4 equals 0. Now we can use either elimination method or substitution method. The elimination method works best when you have the same term in both equations that you can either subtract or add together to eliminate them. But we don't have that. What we do have though is we have y as the subject of the formula in the first equation. And that will make substitution method a lot easier to use. So that's what I'm going to apply here. So using the substitution method, what I'm going to do first, just to make it a little bit easier for myself, is I'm going to start with the second equation. And I'm going to write it as x minus 2 outside of y in brackets. So all I've done is I've just added brackets around the y. Minus 4 equals 0. And the reason for that is because I'm going to substitute out the y, and in its place, I'm going to substitute in 2x plus 1, since y and 2x plus 1 are equal in value based on the first equation. So I'm going to substitute out the y, and in its place I'm going to write 2x plus 1 in the brackets, and that's the significance of adding the brackets around the variable that is going to be substituted out. So now we have an equation involving the variable x only. So x minus 2 outside of 2x plus 1 in brackets minus 4 equals 0. We'll expand the brackets there. And we get x minus 4x minus 2 minus 4 equals 0. So that's minus 2 times 2x is negative 4x. And minus 2 or negative 2 times positive 1 is negative 2. Minus 4 equals 0. Now let's solve this equation. So we'll collect the like terms. So x minus 4x is negative 3x. And negative 2 minus 4 is negative 6, and that equals 0. I'm going to move the negative 6 over to the other side by adding 6 to both sides. So we have negative 3x is equal to positive 6. Dividing both sides by negative 3, we have x equals 6 divided by negative 3. So therefore, x equals negative 2. Now that's only half the solution. We still need the y value that corresponds to that. So we can use the first equation for that. Since y is already the subject of the formula, all I need to do now is just substitute x equals negative 2 into the first equation to then find the value of y. So y is equal to 2 multiplied by negative 2 plus 1. So in place of the x, substituting the value -2 plus 1, and therefore y is equal to -3. And therefore the solution is x equals -2, y equals -3. Question 26e. The times taken for 160 music downloads were recorded, grouped into classes, and then displayed using the cumulative frequency histogram shown. On the diagram, draw the lines that are needed to find the median download time. So notice that it's not asking for the median itself, just the lines that are needed to find the median. Now I've already done the solution. I'm going to explain what I've done. Now the first step is to draw in the ogive. So that's the polygon that joins the bottom left to the top right corner of each column. So you can see that's what I've done there. The next step is to locate half of 160, so the median's the halfway point. Locating half of 160 on the y-axis and then drawing a horizontal line across until it strikes the ogive. And then from that point of intersection, drawing a vertical line down toward the x-axis to locate the median. Question 26F. The weight of an object on the moon varies directly with its weight on Earth. An astronaut who weighs 84 kilograms on Earth weighs only 14 kilograms on the moon. A lunar landing craft weighs 2,449 kilograms when on the moon. Calculate the weight of this landing craft when on Earth. So this is a direct variation question, which is based on the direct variation equation, y equals k multiplied by x, where k is the constant of variation. So rather than using the pronumerals x and y, so x is the independent variable and y is the dependent variable, I'm just going to use the nouns moon and Earth. So moon, or the weight on the moon, is equal to k multiplied by the weight on the Earth. So we need to determine this constant of variation k. And we do that by using the data in the question. An 84 kilogram person on Earth weighs only 14 kilograms on the moon. So substituting those two values into the direct variation equation, so we've got moon equals 14, Earth's equal to 84, so 14 equals k multiplied by 84, making k the subject of the formula by dividing both sides by 84. We have k equals 14 over 84. Now to determine the weight of the lunar landing craft when on Earth. The way we do that is to substitute this weight, 2,449 kilograms, for the moon, because that's what this lunar landing craft weighs on the moon, is equal to k multiplied by the weight of this craft on Earth. So 2,449 equals 14 over 84 multiplied by Earth. Then we're going to make Earth the subject of the formula by dividing both sides by 14 over 84. So 2,449 divided by 14 over 84 is equal to the weight of this craft on Earth. And that's equal to 14,694 kilograms. So therefore, the weight of the landing craft on Earth is 14,694 kilograms. Question 26G. Singapore is located at 1 degree north, 104 degrees east, and Sydney is located at 34 degrees south, 151 degrees east. What is the time difference between Singapore and Sydney? Ignore daylight saving. Now, time difference is dependent on the longitude, not the latitude. So the first coordinates are of no significance. It's only the second coordinates. So what I like to do is to represent those on a number line. So 0 degrees is the prime meridian. That's west, that's east. So Singapore is at 104 degrees east, so it's not to scale, but it just helps to visualize the difference. Sydney is at 151 degrees east. So the further east the location, the further ahead it is in time. Now, every 15 degrees longitude is equal to 1 hour time difference. So how many lots of 15 degrees do we have between Singapore and Sydney is more the question. So the way I worked it out is 151 minus 104 will give the difference in longitude And then dividing that by 15, you get 3.1333 recurring. And then pressing the degrees, minutes, seconds button, that converts that into hours and minutes. So I'll just demonstrate that just to show you. So 151 minus 104, divide that by 15, press equals. Now pressing the degrees, minutes, seconds button, and the answer is in hours and minutes. Question 27A. Alex is buying a used car which has a sale price of $13,380. In addition to the sale price, there are the following costs. Transfer of registration, $30, and stamp duty, at this point unknown. So part 1, stamp duty for this car is calculated at $3 for every $100 or part thereof of the sale price. Calculate the stamp duty payable. Now where it says or part thereof, that implies that the sale price of the car needs to be rounded up to the nearest $100 before we calculate the stamp duty. So even if this was $13,310, you still round it up to the nearest $100 before we apply the calculation for stamp duty. So let's do that. So rounding $13,380 up to the nearest $100, of course we get $13,400. We divide that by 100 and then multiply it by 3 to calculate the stamp duty, and we get $402. Part 2. Alex borrows the total amount to be paid for the car, including stamp duty and transfer of registration. Interest on the loan is charged at a flat rate of 7.5% per annum. The loan is to be repaid in equal monthly installments over 3 years. Calculate Alex's monthly repayments. Now note that flat rate interest is simple interest. So that's using the formula I equals PRN to determine the amount of interest owed. So the first thing we need to determine though is the principal. How much did Alex borrow? So the principal is equal to $30, that's the transfer of registration, plus the stamp duty, plus the sale price of the car, and we get $13,812. So that's how much Alex is borrowing. So the next thing we need to work out is the interest owed on the car. So that's added on. So interest equals principal multiplied by the interest rate per annum multiplied by the number of years. And that gives us $3,107.70. So Alex has to pay this much on top of the principal. So now we need to sort of start to think about the monthly repayments. So before we do that, let's work out the total amount repaid. So that's $13,812. So that's the principal, the amount borrowed, plus the interest. And Alex will need to repay $16,919.70. And the final step is to work out the monthly repayments. So it's over 3 years, 12 months in a year, of course, so that's going to be 36 payments. So monthly repayments equals $16,919.70, dividing that by 36, and we get $469.99 rounded. Part 3. Alex wishes to take out comprehensive insurance for the car for 12 months. The cost of comprehensive insurance is calculated using the following. Base rate, $845. Fire service levy, or FSL, 1% of base rate. Stamp duty, 5.5% of the total of base rate and FSL. And GST, 10% of the total of base rate and FSL. Find the total amount that Alex will need to pay for comprehensive insurance. Now the first thing to work out, I guess logically, is this fire service levy, which is 1% of base rate, which is 1% of $845, which gives us $8.45. The next thing we can work out is the stamp duty. Now that we have the fire service levy, so let's work that out. So that's 5.5% of the total of base rate and FSL. And that gives us $46.94. The next thing to work out is the GST. And it's a similar calculation to stamp duty. So rather than 5.5%, we just replace that with 10%. So GST is equal to 10% multiplied by the sum of 845 plus $8.45. And that equals $85.35. And finally, we just add that all up. So 845, that's the base rate, plus $8.45, which is the fire service levy, plus the stamp duty plus the GST equals $985.74. Part 4. Alex has decided he will take out the comprehensive car insurance rather than the less expensive non-compulsory third-party car insurance. What extra cover is provided by the comprehensive car insurance? Now, third-party car insurance covers damage to property other than one's own. So comprehensive car insurance covers what third-party car insurance covers as well as one's own property. So one way to word the answer to this is covers damage to Alex's car as well as damage to other people's property. Zuso is comparing the costs of two different ways of travelling to university. Zuso's motorcycle uses 1 litre of fuel for every 17 kilometres travelled. The cost of fuel is $1.67 per litre and the distance from her home to the university car park is 34 kilometres. The cost of travelling by bus is $36.40 for 10 single trips. So which way of travelling is cheaper and by how much? And support your answer with calculations. So I think maybe we can start with travelling by bus. So why don't we work that out? Now, one single trip is going to be obviously a tenth of $36.40. So to go to university and back, so it's going to be 2 single trips. So what we can say is that one round trip, so a round trip is sort of back from home to uni, back home again, okay, is equal to $36.40 divided by 10, so that gives you the cost of one single trip. We're going to multiply that by 2 to give us then the cost of a round trip. So home, uni, and back home again. So $36.40 divided by 10, okay, multiply that by 2, and we get $7.28. Okay, so now let's consider the motorcycle. Okay, so it's 34 kilometres, so this is from Zuso's home to university. So one round trip, let's work out the distance first, is equal to 2 times 34, okay, which is equal to 68 kilometres. Okay. So now let's work out how much fuel is actually used. So fuel used. Okay. Now it's 1 litre for every 17 kilometres, and there's obviously 4 lots of 17 in 68. Okay, but the way we can work it out, distance travelled, okay, divided by 17 will give us the number of litres. So that's going to equal 4 litres. So the cost is equal to 4 litres multiplied by the cost per litre, which is $1.67. Okay, so 4 times 1.67, and we get $6.68. Okay, so the motorcycle is definitely cheaper than the bus. And not that the question asks for it, but I'm going to work out what the difference is. So just to make it sort of more complete, $7.28 minus $6.68 by 60 cents. Thank you for watching. Question 27C. The base of a water tank is in the shape of a rectangle with a semicircle at each end as shown. The tank is 1,400 millimeters long, 560 millimeters wide, and has a height of 810 millimeters. What is the capacity of the tank to the nearest litre? So I'm going to treat this as a volume of a prism type question, even though technically speaking it's not a prism because of the cylindrical components of this shape. We can still treat it as a prism. So volume equals area of the base, or is the base of the tank there, multiplied by the height of the tank. And of course we'll need to convert that into a unit of capacity, and we're asked to convert it to litres, correct to the nearest litre. Now, to make that a little bit easier, I'm going to convert all measurements to centimetres, because converting cubic centimetres to litres is quite straightforward. The other thing I need to consider is the radius of the semicircle. So let's look at the base of the tank. We need the area of the base. We can see that it's composed of 2 semicircles, So two semicircles brought together makes a full circle, of course, so we can just consider a full circle. And we have a rectangle in between the two semicircles. So the area of the base is pi times 28 squared, because the radius of the semicircle is 28 centimeters. So 56 centimeters is the diameter. That's how I got the 28. So area of the base is pi times 28 squared plus 140 minus 56. So that's the length of the rectangular part. So that's 28 centimeters there. That's 28 centimeters there. Of course, that's the radius of the two semicircles. And the length of the rectangle is 140 minus 56, and then multiplied by the width of the rectangle. That's 56 centimeters there. So I'll put that all in one calculation, and that results in 7,167.00864 square centimeters. Notice that I didn't round it there. I'm going to round at the very end. Now the next thing is to find the volume of the tank. So we take the area of the base that we just found and we multiply it by the height of the tank. So volume equals A times H. And I multiply it by 81, and that gives us 580,527.6999 cubic centimeters. Now cubic centimeters is equivalent to milliliters. So in fact, I could just cross out the cm3 or the cm cubed and write ml in its place, since 1 cubic centimeter equals 1 milliliter. So to convert that then into liters, or the unit of capacity here in liters, we're going to divide this figure by 1,000, and that gives us 581 liters, correct to the nearest liter. Question 28A. James plays a game involving a spinner with sectors of equal size labelled A, B and C as shown. He pays $2 to play the game. He wins $5 if the spinner stops in A and 50 cents if it stops in B or C. Calculate James's financial expectation for the game. So let's think about this for a moment. James pays $2 to play the game, so he's already lost $2. However, if the spinner lands here in A, he's going to win back $5. If the spinner lands in B or C, he'll win 50 cents. So financial expectation is equal to the dollar win minus the dollar loss. So that takes into account the probability of winning the amounts shown, so $5 or 50 cents. And we know what the loss is already. So the loss is $2. And we can think of financial expectation as the average win or loss per game or per play. And we find this by taking the probability that the spinner lands on A and multiplying it by the amount won. So probability of A multiplied by $5 plus the probability that the spinner lands on B or C and multiply that by 50 cents minus the cost to play per game, or any other losses in fact. But in this case, it's $2. And that's equal to 1/3 multiplied by 5 plus 2/3 multiplied by 0.5 minus $2. So just take into account that this 50 cents, we need to convert that into dollars. Okay, so we need to use the same units. And we find that the financial expectation for the game is $0, which means that on average, the win or loss is 0. Question 28B. A radial compass survey of a sports centre is shown in the diagram. Part 1. Show that the size of angle AOB is 114 degrees. So firstly, let's consider the angle between A and north. So from 320 to north is 40 degrees. So the way we can work that out is 360 degrees minus 320 degrees is equal to 40 degrees. Next, from north to point B is 74 degrees, so 40 plus 74 is equal to 114 degrees as required. Part 2. Calculate the length of the boundary AB to the nearest metre. Let's go back to the diagram. So there's boundary AB. This is part of triangle AOB. Now, the other two sides of the triangle are known, so OA and OB the lengths of those two sides we know, so 287 meters and 211 meters. We also know angle AOB, which was worked out, of course, from part 1, which is 114 degrees. So two known sides and an included angle, so that's the angle in between. So do we use the sine rule or the cosine rule? Now, two known sides and an included angle, we use the cosine rule. So AB squared is equal to 287 squared plus 211 squared minus 2 times 287 multiplied by 211 multiplied by cos of 114 degrees. And that evaluates to 176,151.5018. So I've left everything in exact form. So I just copied down all the characters or all the numbers from the calculator screen, didn't round. And it's good practice to keep values unrounded right up until the very end and then round right at the end. Now we need to take the square root. This value looks far too big for that to be the length of the side of triangle AOB. And I guess that's another check that you can do to sort of, is your answer reasonable? 287, 211, 176,000. So the last step is to take the square root because we don't want AB squared. And we get AB equals 419.704 ... Of course, I don't write all the decimals at this point because we just need the answer to the nearest meter. So AB equals 420 meters. Part 3. Find the area of triangle AOB in hectares correct to two significant figures. So let's go back to the diagram. So we've worked out side AB, which is 420 meters, but that's a rounded figure, so I'm not going to use that. But I will use side OA and OB since these are far more accurate, and that's the original data that's supplied in the question. And we also know angle AOB, of course we've worked that out previously as well, which is 114 degrees. So just like the cosine rule, we can use the area rule for a triangle because we have two known sides and an included angle. So that's the half AB sine C formula. So let's do that. So area equals half times 287 times 211 times sine of 114 degrees. And just expressing the answer without rounding, it's 27,660.78614 square meters. Next, we need to convert that to hectares, and there are 10,000 square meters in a hectare. So we'll divide that answer by 10,000. And that gives 2.766 ... hectares. Now the ... just means that there's more decimals. However, we need to answer correct to two significant figures. So we're only interested in the first number and the second number, so the 2 and the 7. The number after the 7 just determines whether the 7 stays as a 7 or whether it gets rounded up. And because the value after the 7 is 5 or more, the 7 needs to be rounded up to an 8. So the area of this triangle is 2.8 hectares, correct to two significant figures. Question 28C. A fair coin is tossed 3 times. Using a tree diagram or otherwise, calculate the probability of obtaining 2 heads and a tail in any order. Now it's a fair coin, which means the probability of tossing heads or tails is 50% or 0.5. That lends itself well to not just using a tree diagram, but other ways of listing the sample space. Now I'm going to use a two-way table to list the possibilities, and it looks something like this. So the fair coin is tossed 3 times. So the first 2 times is represented by the columns, and the third time, or the third toss, is represented by the rows. So we have heads, 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 that's one of the possibilities, right through to tails, tails, tails. That's the 8th possibility. So there's 8 possible outcomes. So we're interested in the outcomes that have a H, and a T in any order. So H, H, H is out, of course. H, H, T is in. H, T, H is in. And the only other one is T, H, H. So there's 3 outcomes, or 3 out of the 8, that have 2 heads and a tail in any order. So therefore, the probability of a heads, heads, or tails in any order is 3/8. Question 28D. An aerial diagram of a swimming pool is shown. The swimming pool is a standard length of 50 metres but is not in the shape of a rectangle. So part 1, by measuring the length AB, determine the scale of the diagram. So this is where you get a ruler and measure the length AB, and it's 8 centimetres. So the scale can be written as 8 centimetres equals 50 metres. But we need to simplify the scale by dividing both terms by 8. So 8 divided by 8 is 1 centimetre, and 50 divided by 8 is equal to 6.25 metres. So the scale can be written as 1 centimetre equals 6.25 metres. Now part 2, using this scale, calculate the length xy of the car park in metres. So again, we'll just measure this interval xy on the map, and that works out to be around 5.1 centimetres. And so using the scale, length xy on the map is 5.1 centimetres. Taking that length on the map and then multiplying it by the scale, 6.25, we get 31.875 metres. Question 29A. The cost of hiring an open space for a music festival is $120,000. The cost will be shared equally by the people attending the festival, so that C in dollars is the cost per person when N people attend the festival. So part 1, complete the table below by filling in the 3 missing values. So the values are found by taking 120,000 and then dividing it by the number of people attending. So it's one of those situations where the more people that attend, of course, the cost is shared, so the cost should be cheaper per person. So 120,000 divided by 3,000 will equal $40 per person. 120,000 divided by 2,500 people will equal $48 per person. And 120,000 shared among 2,000 people results in $60 per person. So to find the cost per person for the number of people attending when there's 500, 1,000 or 1,500, again we follow the same pattern. 120,000 divided by these 3 values, you'll get $240 per person for 500 people attending, $120 per person for 1,000 people in attendance, and $80 per person for 1,500 people in attendance. Okay. We can also see that for 1,000 people, it's $120. If you double the number of people, so $2,000, it should be half the cost. Now, one way to check your answer would be if you take the cost per person and then multiply it by the number of people, you should get $120,000. So, in fact, 240 times 500 will give you $120,000. 120 times 1,000 will give you $120,000, and so on. Let's have a look at part 2. Using the values from the table, draw the graph showing the relationship between N and C. Now, the top row of the table of values corresponds to the x-axis or x-axis coordinates, and the bottom row, of course, corresponds to the y-axis or y-axis coordinates. So I'll just reveal the graph, and it should look something like this. Okay, so each column represents a coordinate pair. So, for example, 500, 240. So locate 500 on the x-axis, and then project upwards until you reach 240, mark a point, and then just mark all the points in turn that correspond to all the columns, and then just a neat sketch of the graph there. Okay, let's have a look at part 3. So what equation represents the relationship between N and C? So it's clear that the number of people in attendance, the more people that attend, the less the cost or the lower the cost per person. So this is a type of inverse variation relationship. So C varies inversely with N, so it'll follow an equation which looks like C equals K over N, where K is the constant of variation. So as N gets bigger, C gets smaller. And K, of course, is 120,000 because K is what is shared among N people. So the equation would be C equals 120,000 over N. Part 4. Give one limitation of this equation in relation to this context. Now this is an open-ended question, which means there's more than one correct answer, and you only need to state one limitation. I'm going to go through a few suggested solutions, so there's obviously more than this, but these are the ones that I came up with. So if one person attends, the cost for that person will be $120,000 according to the model, which is unrealistic given the context, which is a music festival. So it doesn't make sense for one person to attend. Another limitation would be that N is limited by the capacity of the venue. So we can't have an infinite number of people attending. So there needs to be also an upper limit to the number of people in attendance. N must be a positive integer. Doesn't make sense to have a negative 10 people attending or 100.2 people attending. And so on. And part 5, is it possible for the cost per person to be $94? And support your answer with the appropriate calculations. So we need to work backwards. So we're going to use the inverse variation equation. C equals K over N, where K is 120,000. And we're going to solve for N. So if the cost per person is $94, we know that to hire the venue is $120,000. So let's solve for N. So how many people would need to be in attendance so that each person pays exactly $94? So solving for N, if you multiply both sides of the equation by N, we have 94N equals $120,000. And dividing both sides by 94, so to make N the subject of the formula, so N equals 120,000 divided by 94. And we get N equals 1,276.5957 and so on. So it's a decimal answer. But we've seen before that N represents the number of people. So it does not make sense to have 1,276.5957 people attending. So N must be a whole number or a positive integer since it represents the number of people. So therefore, it is not possible to have a cost per person of $94. Question 29b. What is the maximum number of standard drinks that a male weighing 84 kilograms can consume over 4 hours in order to maintain a blood alcohol content, BAC, of less than 0.05? And the formula for BAC is BAC for a male equals 10N minus 7.5H over 6.8M, where N is the number of standard drinks, H is the number of hours drinking, and M is the mass of the person in kilograms. So what do we know? We know that M equals 84, we know that H equals 4, and we know that BAC is equal to 0.05 because what we're interested in is to find the number of standard drinks or the maximum number of standard drinks that this person can have while at the same time keeping the BAC less than 0.05. So the strategy here is to substitute in the known values into the formula and then make N the subject of the formula. So 0.05, so that's the BAC, equals 10N minus 7.5 times 4, since 4 is the number of hours, all over 6.8 multiplied by 84. And 84, of course, represents 84 kilograms, the mass of the person. So simplifying this fraction somewhat, we have 0.05 equals 10N minus 30, so 7.5 times 4 is 30, all over 571.2. So we need to multiply both sides by 571.2. So we have 0.05 multiplied by 571.2 equals 10N minus 30. And just simplifying the left-hand side, so 0.05 multiplied by 571.2, and that gives us 28.56 equals 10N minus 30. So we can add 30 to both sides. We have 28.56 plus 30 equals 10N. And simplifying the left-hand side again, we have 58.56 equals 10N, or 10 times N. The next step would be to divide both sides by 10 to make N the subject of the formula. So N equals 58.56 divided by 10, N equals 5.856. So that represents 5.856 standard drinks, but the number of standard drinks needs to be a whole number. Now, if n equals 6, the BAC will be over 0.05. And the question clearly states less than 0.05. So this person cannot consume 6 standard drinks. So we cannot round this number up to 6. So n must be an integer, of course, so it can't be decimal for starters. And we also need to round down to the nearest whole number so that the BAC is kept below 0.05. So therefore, the maximum number of drinks is 5.
Question 29C. Terry and Kim each sat 20 class tests. Terry's results on the tests are displayed in the box and whisker plot shown in Part 1. Part 1. Kim's 5-number summary for the tests is 67, 69, 71, 73, 75. Draw a box and whisker plot to display Kim's results below that of Terry's results. Now, the 5-number summary is in ascending order and corresponds to the minimum score, the first quartile, the median, the third quartile, and the maximum. And it should look something like this. Part 2. What percentage of Terry's results were below 69? Now, the score of 69 corresponds to Terry's median score. And the median is a number that cuts off the bottom 50% of scores from the top 50% of scores. So the answer to this part is 50%. In part 3, Terry claims that his results were better than Kim's. Is he correct? Justify your answer by referring to the summary statistics and the skewness of the distributions. Now, the first point to note is the median for Terry is 69, well, the median score for Terry is 69, which is lower than Kim's median of 71. And that's evident from the box and whisker plots. The next point to note is the distribution for Terry is positively skewed, while Kim's distribution is symmetrical. And that can be seen by looking at the location of the median relative to the quartiles, or the position of the quartiles, and also the minimum and maximum scores. So we can see for Terry's results, the median is pushed, or it looks like it's pushed to the left-hand side. So much closer to the minimum score, and as well as the first quartile compared to the maximum score and the third quartile. Whereby for Kim's box and whisker plot, the median seems like it's in the middle, or midway between the quartiles and also between the minimum and the maximum scores. The next point to note is that 50% of Terry's results are greater than 69, whereas 75% of Kim's results are greater than 69. So again, referring back to the box and whisker plots, the score of 69 corresponds to the median for Terry, but it corresponds to the first quartile for Kim's box and whisker plot. So that means that 75% of Kim's results are above 69, whereby for Terry, only 50% of his results are above 69. Now, Terry's range and interquartile range is 9 and 6 respectively, and that's larger than Kim's range and interquartile range, which is, I'm just moving this paper up a little bit, which is 8 and 4 respectively. So the lower the range and or the interquartile range, it means the more consistent the results. So Kim's results are more consistent than Terry's. So therefore we can conclude that Terry is not correct.
Question 38. Chandra and Sasha plan to have $20,000 in an investment account in 15 years' time for their grandchild's university fees. The interest rate for the investment account will be fixed at 3% per annum, compounded monthly. Calculate the amount they will need to deposit into the account now in order to achieve their plan. So the amount they need to deposit here and now, present, is the present value, which is unknown, and that's what we're trying to find. The future value, so that's the value in 15 years' time, according to this plan, is $20,000. So we'll use the formula future value equals present value multiplied by 1 plus r, all to the power of n, where r is the interest rate per period and n is the number of compounding periods. And we need to solve for PV. So what do we know? We know the future value is $20,000. Now the interest rate per period is 3% divided by 12, so that's 3% per annum, and there's 12 months in a year, so 3% divided by 12 is interest rate. And the number of compounding periods is 15 years multiplied by 12 compounding periods per year, so that equals 180. And the present value, we have no idea about. That's what we're trying to solve. So we need to solve for the present value. So substituting in what we know, 20,000 equals PV multiplied by 1 plus 3% over 12 all to the power of 180. We need to make PV the subject of the formula. So we're going to divide both sides of the equation by what's in the brackets. So that's 20,000 divided by 1 plus 3% over 12 to the power of 180 equals PV. And evaluating the left-hand side, we get the present value equals $12,759.73. And that's the amount that will need to be deposited into the account now in order to have a future value of $20,000. Question 30b. The scatter plot shows the relationship between expenditure per primary school student as a percentage of a country's gross domestic product, GDP, and the life expectancy in years for 15 countries. So part 1. For the given data, the correlation coefficient R is 0.83. What does this indicate about the relationship between expenditure per primary school student and life expectancy for the 15 countries? So this question is about interpreting this number, 0.83. Now it's fairly close to 1. So we can conclude that there is a strong positive relationship or a strong positive correlation between expenditure per primary school student and life expectancy. Or you could state that the greater the expenditure per primary school student, the greater the life expectancy. Part 2. For the data representing expenditure per primary school student, QL is 8.4 and QU is 22.5. What is the interquartile range? Now the interquartile range is given by the formula QU, or upper quartile, minus QL, or lower quartile, and that's 22.5 minus 8.4, given the information in the question, and that gives us an interquartile range of 14.1. Part 3. Another country has an expenditure per primary school student of 47.6% of its GDP. Would this country be an outlier for this set of data? Justify your answer with calculations. Now firstly, 47.6% appears significantly bigger than the upper quartile of 22.5%. So firstly, we need to determine what the outlier upper boundary is, and then check if 47.6% exceeds that upper boundary. So the outlier upper boundary is given by the formula upper quartile plus 1.5 multiplied by the interquartile range, and we found that in part 2. So substituting in the values for QU and IQR, we get 22.5 plus 1.5 multiplied by 14.1, and that gives us an outlier upper boundary of 43.65%. And clearly 47.6% exceeds 43.65%, so therefore 47.6% is an outlier. Part 4. The expenditures per primary school student for the 15 countries in the scatter plot are 5.9, 7, 7.6, all the way through to 27.6. Complete the table below by calculating the mean, x bar, and the standard deviation, sigma x, of these data. Calculate both values to 2 decimal places. The table also shows the mean, y bar, and the standard deviation, sigma y, of life expectancy for the same 15 countries. So calculating the mean and the standard deviation, we need to use the stat mode on the calculator. So press mode and choose stat. Now on this calculator, the FX100 AU plus, it's number 3. On the FX82 AU plus or plus 2, it's mode 2. Okay, so 1 var, and then just type in the data. So 5.9, 7, 7.6, So all the way through to 27.6. Okay. Press the AC key. Then press Shift 1. I'm going to go to var, so number 4 here. And number 2, X bar. And we get 16.14. And for the standard deviation, sigma x. Okay, so press number 3. And we get 7.02745, but rounding that to 2 decimal places, that's 7.03. And this is what we obtain. Part 5. Using the values from the table in Part 4, show that the equation of the least squares line of best fit is y equals 1.29x plus 49.9. So here are the values from the table in Part 4. Now we also need the formulas for determining the gradient and the y-intercept of the least squares line of best fit. And they may be found in the formulae and data sheet under least squares line of best fit. So that's this formula here and this formula here. And I've just written them here as part of the solution. So we need to determine the gradient first, and then using the gradient, we can then determine the y-intercept. So the gradient equals 0.83, correlation coefficient, multiplied by 10.94 divided by 7.03 in brackets, or you can write it as a fraction. And we get 1.29, correct to 2 decimal places. And we can use this value to determine the y-intercept now. So using this formula here, that's 70.73 minus 1.29 multiplied by 16.14. And we get 49.9, correct to 1 decimal place. So therefore, the equation of the least squares line of best fit is y equals 1.29x plus 49.9 as required. Part 6. On the scatter plot on page 30, draw the least squares line of best fit, y equals 1.29x plus 49.9. Now to locate and draw a line, you need a minimum of 2 points. Now one of those points is the y-intercept of 49.9. So that's given already. So to determine the coordinates of a second point, choose an appropriate value of x, substitute it into this equation, and then find the value of y that corresponds to that value of x. So I chose x equals 30 as the x coordinate of my second point. Substitute x equals 30 into this equation, and the y value that corresponds to the x value of 30 is 88.6. So plotting those 2 points on this grid, there's the y-intercept, 49.9, so it's approximately 50. And when x equals 30, y equals 88.6, so that's approximately here in this location. Joining those 2 points, we get the graph of the least squares line of best fit. Part 7. Using this line or otherwise, estimate the life expectancy in a country which has an expenditure per primary school student of 18% of its GDP. Now there's 2 ways we can answer this question. Using the line as stated, and we do that by locating 18 on the x-axis, projecting upwards until we strike the least squares line of best fit, and then projecting across to the y-axis, and we get a value that's fairly close to 74 years. The other way to work it out is using the algebra by substituting x equal 18 into the equation and then determining the value of y when x equals 18. So letting x equal 18, y equals 1.29 multiplied by 18 plus 49.9, and we get 73.12 years, or 73 years if you want to round it to the nearest whole number. Or if you use the line, it's 74 years from the graph. Part 8. Why is this line not useful for predicting life expectancy in a country which has expenditure per primary school student of 60% of its GDP? Now, to help you think about a response to this question, let's have a look at the least squares line of best fit that we drew earlier. So there's x equals 30% there. So 60% is way off to the right-hand side. And I guess the question is it safe to assume that this trend will continue forever and ever, or all the way up to 100%? And something else to think about is when x equals 60, calculating the life expectancy when x equals 60% gives us a life expectancy of 127.3 years. So clearly that does not sound reasonable. So the least squares line of best fit is based on x values from 5.9% to 27.6%. So that's what we've said before. It cannot be assumed, though, that the trend will continue in the same way beyond x equals 27.6%. So extrapolating beyond x equals 27.6% would therefore be invalid.